Personal Expense Tracker application.
Assalamualaikum, this is our demonstration of our Personal Expense Tracker app. In this video, I will walk you through features of the app. First, user will be met with a login interface. User will need to input their username and password and press the login button. If they proceed to press the Remember Me button, user data will be saved in the local storage, so they doesn't need to input their username and password again. So here, I'm inputting my username. And now, insert the password. And press the login button. And now, user will be met with a personal expense tracker interface. First, we will add a budget. The budget will be shown in the total budget and budget left, where it will be minus the total expense. Next, we go to the add expense. In the type of expense, user can choose the type of expense that they want to use. For example, grocery. And then we're gonna type the amount of expense that the user spent. For example, 40. So now user can choose the date, and when they press the Add Expense button, it will show a donut graph. And the Edit button. If you press the Edit button, user can edit the data. For example, we want to change to 50 ringgit. So now it will become 50 ringgit in the donut chart. And if user press the Remove button, it will remove the expense totally. Here, I'm adding another one expense to show the remove example. As you can see, it still add up in the donut expense chart. And then we proceed to press the remove button. The data will be removed from the donut chart. And now if we press the reset all button, everything will be reset to 0.
So, this is adding function code. When a user submit the expense form, the JavaScript code retrieves the input values for the expense title, amount, and date. Then, it validates the input to ensure they are not empty and the amount is valid number. If the number is valid, a new expense object is created with the provided detail. This expense object is then added to the budget data expenses array, and the total expenses and budget left are updated accordingly. Finally, the local storage is updated with the new expense data, and the UI is refreshed to display the updated information. Next, this is for edit code function. The edit expense function is called when a user click the edit button next to expense item. This function takes the index of the expense to be edited as a parameter. It retrieves the expense object at that index from the budget data.expenses array and pre-fills the expense form with its detail. The expense is then removed from the array to allow for editing, and the total expenses and budget left are updated accordingly. Finally, the local storage is updated and modified the expense data, and UI is refreshed. Okay, so this is delete function code. The remove expense function is triggered when a user click the remove button next to an expense item. It takes the index of the expense to be deleted as a parameter and remove that expense from the budget data.expenses array. The total expenses and budget left are then updated accordingly, and the local storage is updated and modified expense data. Finally, the UI is refreshed to reflect the changes. So this is view summary code. The update chart function is responsible for updating the chart that visualizes the distribution of expense across different categories. It calculates the total amount spent on each expense category and dynamically generates labels and data for the chart. If the chart already exists, it is destroyed and recreated with the updated data. The reset functionality allows users to clear all budget and expense data, effectively resetting the application to its initial state. The reset budget function is called when the reset button is clicked. It sets the budget data objects to its initial state with zero total budget, zero total expenses, and an empty expenses array. Local storage is used to persist the budget and expense data across browser session. The update local storage function is called whenever there are changes to the budget or expenses. This function converts the budget data object into a JSON string and save it in a browser local storage under the key budget data. The load from local storage function is called when the application initialized to check if there's any saved data in local storage. If data is found, it is parsed and loaded into the budget data object and the UI is updated accordingly. Challenge during development. First is data persistence. The challenge is to ensuring that budget and expense data persist between sessions. So the solution we identify is utilizing local storage to store budget data, which keep the data even when the user closes and reopens the browser. This involves handling JSON serialization and deserialization to read and write data to local storage. Second is form validation. The challenge is ensuring user enter valid data for both budget and expense. So the solution is implementing comprehensive form validation logic to check for valid number, non-empty inputs and valid dates. This includes checking if the budget amount is positive number, ensuring the expense amount is a positive number and the date is valid. Also providing feedback to a user through alerts or inline error message if the input is invalid. Next is dynamic content update. The challenge through is dynamically updating the UI to reflect changes in budget and expenses. The solution we identify is by creating function like update UI that update the DOM based on the current state of budget data. This involves manipulating the DOM to display the latest data, rendering expense item in the table, updating budget, total expense and budget left values. So implementing logic to dynamically update the chart with the latest expense data. And last is chart integration, which is the challenge is visualizing expense data effectively. So the solution integrating chart.js to create a donut chart that dynamically updates as expenses are added or removed. The key steps include setting up the chart configuration with dynamic labels and data, writing a function to update the chart data, and re-render it whenever expense change. And last as managing the chart life cycle to properly update and destroy the chart when necessary, ensuring accurate and responsive visual representation of expense data. For the design decision, first we use a Bootstrap for responsive design. The reason is because Bootstrap is a popular front-end framework that make it easier to design responsive and mobile-first website. By using Bootstrap, the app ensures a consistent look and feel across different devices and screen size. The implementation is the grid system and styling component. Like utilize Bootstrap grid system like row and column to create a flexible layout for the budget and expense input form as well as the display area. And for the styling component, we leverage Bootstrap predefined style for button, form, alerts, and table to ensure a cohesive design without needing to write extensive custom CSS. Second is HTML structure. Have a clear and semantic HTML structure help in organizing content logically and making it accessible. So the implementation is in forms and container and division. In the form is separate form for adding budget and expense are created to keep the user input distinct and well organized. And next is for container. We use container to group related element like budget information, expense history or chart, making the structure clear and easy to manage. Then in the JavaScript for dynamic functionality, the reason is JavaScript is essential for adding interactive element and dynamic updates to the app. So the implementation is like event listeners. We used to handle form submission, button click and page load events. So trigger appropriate action like adding budget or expense, update the UI and resetting the data. Next is like data management. We maintain the state of application using an object, budget data, and store it in local storage to persist data between sessions. Then is DOM manipulation, function like update UI, edit expense, and remove expense. Directly manipulate the DOM to reflect changes in the app state. And then we also use CSS for custom styling because it used to enhance the aesthetic beyond what Bootstrap offer, ensuring the app has a unique look. And then local storage for data persistent. We use local storage is a simple way to store data in browser, allowing the app to remember user input across session. And why we use this design? Because it user-friendly interface and interactive, dynamic, visual feedback, and also persistent data. That's all from us. Thank you.